All right, welcome. Today we're diving deep into the world of professional risk analysis. We're going to see how the pros take something as vague as uncertainty and turn it into a real, practical tool for making way smarter decisions. So it all starts with this one big problem. We just love a single, simple number, don't we? This project will cost 10 million pounds. This task will take 3 weeks. But as this quote from PricewaterhouseCoopers points out, that single number, it's basically a trap. It's dangerously incomplete if you don't understand the uncertainty swirling around it.
And that leads us straight into what you could call the certainty illusion, this really common trap of thinking that one single forecast is the absolute truth. Let's see what that actually looks like.
Okay, so imagine you're looking at two projects. On paper, they both look identical, an expected value of 10 million pounds each. Easy choice, right? But hold on, look at the fine print. Project A could swing up or down by 1 million. Project B, though, that one could swing by 3 million. All of a sudden, they don't seem so equal, do they? Which one would you pick? The thing is, your answer completely depends on how much risk you're willing to stomach. So to really see what's going on and make the right call, you have to get past that one number. And this is the key. Professionals don't just guess. They use a very clear, very structured process to map out all that uncertainty. And that process, well, it's a formal 4-phase framework. You can think of it as the roadmap that experts use to get from a simple hunch to a really sophisticated understanding of all the things that might happen. And here they are, the 4 phases we're going to walk through. First, you identify the risks. Simple enough. Second, you quantify them. You put some numbers on them. Third, you analyze how they all fit together. And finally, the most important part, you present the results so you can actually make a decision. So let's start at the top with phase 1. Phase 1 is all about identification. Before you can measure anything, you've got to find it first, right? So how in the world do you create a master list of every single thing that could possibly go right or wrong? Well, it's definitely not a solo mission. The best way to do this is by getting everyone in a room for some serious brainstorming. You bring in the engineers, the project managers, the financial folks, outside consultants, everybody. Each person sees the project through a totally different lens, and that is absolutely crucial for spotting risks that any one person would have missed. Now, all of this brainstorming gets poured into one critical document, the risk register. Just think of it as the project's official master list of everything that could happen. For every single risk, you write down a clear description, and then you give it a quick first-pass rating. Is the impact high, medium, low? Is it likely to happen? This document becomes the bedrock for everything else we're going to do. Now, this identification phase sounds pretty straightforward, but there is a classic trap that so many people fall into. Any ideas what it might be? Yup, the answer is double counting. This is when you list two different risks that are actually just two sides of the same coin. For example, you might list the risk of not having enough resources, and also list the risk of getting fined for poor performance. But really, those are connected. They're two different outcomes of a single problem. You're either going to spend more money on resources to avoid the penalty, or you're going to save money and risk the penalty. You can't count both as separate risks. Okay, let's move on to phase 2, quantifying. We've got our big list of risks. Now we have to turn those descriptions into something we can actually measure. And this is where things get really cool, because this is where we literally give risk a shape. We do that using something called a probability distribution. Now, it sounds a little technical, but the idea is super simple. Instead of saying the cost is going to be exactly 10 million, a distribution shows you the probability of every single possible cost. It turns that single misleading dot on a chart into a rich picture of all the possibilities. It's a shape, not a point. And analysts have a whole toolkit of these shapes to choose from. The most common one you'll see is the triangular. It's great because it's so intuitive. You just ask the experts for 3 numbers. What's the absolute minimum it could be, what's the absolute maximum, and what's the most likely number? That's it. It's a fantastic place to start. Then, of course, you've got the famous bell curve, the normal distribution. This one is perfect for things that tend to bunch up around an average, like, say, inflation rates or small measurement errors, where really extreme outcomes are pretty rare. And what about when you're really uncertain? For that, you use the uniform distribution. This flat shape just means that any outcome between your minimum and maximum points is equally likely. You use this when you know the boundaries, but you have absolutely no idea what's most likely to happen in between them. So what do we do with all these cool shapes? We feed them into something called a Monte Carlo simulation. Don't let the name intimidate you. All it is a computer model that runs your project scenario over and over and over again, thousands of times. Each time it runs, it picks a random number from each of your wrist shapes and calculates the final result. By the end, you have this huge collection of possible futures.
And those thousands of simulations bring us to our final phases: analysis and decision. This is the payoff. This is where we take that massive pile of data about possible futures and turn it into something clear enough to make a real-world decision. See? After running thousands of simulations, you don't get one neat little answer. No way. You get this, a complete map of all the possible outcomes. This curve shows you the probability of the project costing 9 million, or 10 million, or maybe even 13 million. This is phase 3, analysis. You can now dig in and see which risks are actually driving the final number, which helps you focus your energy on the threats and opportunities that really, truly matter.
And this brings us right to phase 4, presenting and deciding. Because the whole point of this entire process, it's not to get a crystal ball and predict the future. It's to understand the entire landscape of possibilities, so you can make the absolute best decision you can today. With a map like this, you can have a totally different kind of conversation. Instead of just saying it will cost $10 million, you can say there's an 80% chance the cost will be under $12 million, but only a 10% chance it'll be under 9.5. Now that empowers people to make a choice that fits what they're actually comfortable with. So once you stop chasing that one single certain number, and instead you look at the whole map of uncertainty, the question you ask completely changes. It's no longer what is going to happen. Instead, it becomes a much more powerful question. Which risks are you willing to take?